the application examples. And let me share my screen. So in the folder that the Birgitte provided you with, you can find the subfolder called hands-on, and then in the number 4 you will find the application usage. These are the most common software that are being used in Kebnekaise, but there are also other software, as I mentioned before, that can be developed by yourself, and then you want to install it. It's possible. And there are also some software that cannot be installed in the entire cluster, but it can be installed in your personal account uh, because of the license, type of license that the software had. And yes, but I will go through these examples, and I also provide you with some exercises, not for all the packages, but for the most common ones. And there are also the README files where you can find a way to submit the scripts, and I will ask you to do that to see how it works. So let me go to the first code, and this is Amber. So in Amber, you can see the README file here, and these are the two examples or the most common cases that you can run in Amber, and one of them is with MPI PMED. Yes, and the way of running Sander is essentially the same, right? Just change the name of the engine here. And also the GPU example, yes, which uses the single precision, fixed precision version of CUDA. So you can go to the test case here, and here there are the two batch scripts. So in this part, change the string project ID with the SNIC project that Birgitte mentioned, and this should be the SNIC 2021, then dash 22 and 514. And in order to run that faster, you need to add the reservation flag for the CPU. This code will run on the CPUs because here we are using the Amber version without the CUDA implementation, right? So no CUDA module is loaded, so it means that you will use only the CPUs. And this is the traditional way to run the Amber with a PMD. And notice here that I'm adding the srun command. And it means that the script will recognize how many MPI tasks will be used here. In the present case, because I'm selecting one node here, N capital 1 and N lowercase 28, it means one node and 28 MPI tasks, right? So this command srun is a wrapper to get this these values for the number of MPIs. So the complete example can be found here in this website. You can change also the number of cores that you want. In this case, I'm using a full node, or you can also use a less number than this in order to see the performance of Amber. So now let me go to the GPU case. So the difference in this script is that I'm now selecting the number of GPU cards that I will use. In this particular case, I will use two K80 cards. And then the next difference is the modules that I'm loading. So here, for instance, I'm loading the CUDA module. And notice that the Amber version is the 2020. Also, the way of running Amber is a bit different because here we need to specify the PMD CUDA implementation with single point, single precision, fixed precision, and MPI. And SRun will get the values for the number of MPIs that are written here, right? In particular, in this case, I will use 4 MPIs. Another way of running the same script is by using the MPI run command. This one is more flexible in case that you don't want to use all the GPU cards, or yes, you want to run several instances of Amber and not occupy the whole resources for the same simulation. So this is another way to run it. But if you run that with SRun, then it will take automatically the parameters that you write here, right? It's just that this one is more flexible, but essentially it's the same. So notice that if you request the number of CPUs here, sorry, the number of GPUs here, but you don't load the correct modules for CUDA, in particular this CUDA module here, so then you will be using only the CPU version of Amber. So it means that you will be accounted for more hours than you should, and the performance of Amber won't be that good because you will not be using any GPU at all. So you need to specify two things correctly: the CUDA modules and also the type of GPU card. As Brigitte mentioned before, instead of K80, you can specify the V100. But in that case, here in the last number, you can use only 1 or 2, right? And in the K80 case, you can use 1, 2, or 4. So let me show you briefly how it works. I will do this on my terminal, which is here. As you mentioned before, you can use PuTTY, but in the present case, I will use a MOBA Xterm. It's another software for connecting to the cluster. I have done it before, and now I am in the intro course folder. I will go to hands-on, then to the application usage. And first I will go to Amber. So here there are the two examples that I mentioned. And first I will deal with this MPI job. And the things that I need to change here are the project ID. I will change the name. Can I write SNIC 2021 and 514. In addition to this, to reduce the queue in time, I will write a reservation. And this is intro HPC. Yep, that's it. So in principle, that should work. And once I have corrected the script, I can submit it with SBatch and the name of the script. Notice that here you get a number, and this is called job ID. Now I can check the status of the job. And here it is the job that I just submitted, right? I have other jobs running, but this is the important one, the Amber case. So what can I do with this number here? Something very useful. I can copy this number and then write job usage and put this number here. And this will output a URL. I can copy this output and then paste it in my local browser. Yeah. So this will tell me the statistics on how the cluster or the resources that I requested for are being used. So something useful is that here on the top right corner, I can select a lower time for updating, and then I can refresh a little bit. So here you can see how well the resources are being used. I requested for 28 cores, and it seems that for a present simulation, 82% about that is being used for the whole resources. So, but it depends strongly on the type of software that you are using. I would expect a better performance for Amber, but in the present example, it's not the case. Maybe the system is small enough to take advantage of it. So the script is very fast, it's short. So, but even in that case, I could see the statistics. And now imagine that I want to run the GPU case. Then I can open the GPU script. I also modify this. And in this case, for the GPUs, the name of the reservation is intro HPC GPU, right? I'm asking just for 10 minutes, 4 MPIs, and and 2 GPU cards. So now I submit the job with this command. Check the queue, and it's running. Again, I can check the job with job usage and the job ID, get the URL, and see how the statistics look like. Let me reduce the time. So it takes some minutes to get the good statistics. But as you can see here, you can get the memory usage, the CPU usage, and also the GPUs if you requested some number of GPUs. So if the script is very short, you won't see any statistics. Yeah? So it needs to take some time in order to show a good statistics. Let me check. No, it was very short. And if we take a look, maybe, yeah, it finished at just after 35 seconds. So it's not enough to get the statistics from this graphical interface. But if your job takes a long time, then it's good or a bit good practice to monitor how good the resources are being used. Sometimes it could happen that, as I mentioned before, you don't load the correct modules, and you request for some GPUs, right? And you think that you're running the job on the GPUs, but you forgot to load the correct CUDA module, and then you will end up using only the CPUs. So this is how I get a good performance with Amber, in particular on the GPUs. If you see here, I'm requesting for 2 GPU cards, but the best performance is achieved with 4 MPIs. And why is that? Because each card here contains 2 GPU engines, and this is what the software recognizes. So in total, it will show you 4 visible devices, and that's why if you request 4 MPIs, then each MPI will use a single GPU engine. And this is the way that you can achieve the best performance here. Okay, let me go to the next software. You can try this software if you have uh, some questions, or you are interested in particular in Amber. You can try also your own script, and then at the end we can check if you have any question, or there is some issue with this package. The next software is GROMACS, and there are several exercises here that I put, yeah? And then you can take a look at them. There are 3 cases. One is the GPU, and the MPI, and also a case which uses virtual sites. This is very interesting because with the virtual sites, you can increase the time step of the simulation and achieve a longer simulation sampling. So in this file here, you can find all the exercises that I provide you with. You can follow them and let me know if there is some issue. Let me see what else I can say on GROMACS. Or maybe I will submit just a single job. The first one, GROMACS. I will go to the MPI folder and take a look at this job MPI GROMACS. Here in the strings marked with a fix me, you can change the number of MPIs with a minus n letter, and this minus c means the number of OpenMP threads. So for instance, on a node, you can choose, let me change this, 2021. On a single node, the best performance can be achieved with 7 MPIs and 4 OpenMP threads, because this will give you a total of 28 cores, right? You have this constraint when you submit your jobs with the GROMACS. The number of MPIs times the number of threads should be a multiple of 28 if you are using multiple nodes. In the present case, because we have only one node, this product should be 28. You can use any combination, for instance, 3 MPIs and 8 OpenMP, but that would not be very efficient, because then you will be using 24 cores, right? The GROMACS version that I'm using is this one, 2020 21, right? And here I'm fixing the number of OpenMP threads with the environment variables here. And this is the way that I used to run the program. EMX, MPI, and MD-run, right? So I will use also the reservation. And check the queue, so it is running. Then I can monitor again the performance of the job and see how good are being used these resources. So let me see if it runs. It's running. So if you're not using GPUs, you won't see the GPU graphic here. So it helps if I refresh it. It takes some minutes, and yes, but then you can see the statistics in this way, right? So please go ahead and try the exercises that I put for GROMACS. And if there is any question, then I can address that here or in a breakout room. So let me go to another package that is useful. Now you can see I got the statistics. So you need to wait a bit. So it says about 70% of the resources are being used. So, okay, so let me go to the next software. So GitHub is taking some time. I don't know why. Now my connection is not good. No, it's back. Okay, so the next example is for LAMMPS. Interesting. So, okay, I will go to the folder here on the terminal. And here I have some examples for the MPI simulation and also for a GPU case. If you take a look at the script job MPI, you will see here how to load the module for LAMMPS and the way to run that. Yeah. Again, I changed it. And add the reservation. Then just submit the file. And it's in the queue. I will cancel this GROMACS job because we got already the statistics. Now it's running. And I can also check the performance of this job. Then you get the statistics after some minutes. Let's wait a little bit. And on the while, I will go to a GPU test case. So go to the folder GPU within the LAMMPS folder. And here you will find the script. One script is for the CPU case and one is for the GPU case. Notice that here the test case is for a Lennard-Jones model, while in the previous example, I was simulating a protein in a water environment. So this is more simple, I would say. But here, the only difference is that I will run purely on CPUs, a whole node, and here I will use the GPU on a node. So you can see the difference by running these two scripts. You can see how is the performance if I use a GPU compared to that on the pure CPU case. So let me see if I got some statistic here. I got first the memory, but I was more interested in this part. But it takes some minutes, as I said. Okay, let me go to the next software, and this should be MATLAB. I will try to run the MATLAB interface here, but because I'm using the mobile extern, my 10-link client is not working well now. So I will run the example on the mobile extern terminal, and I'm not sure if I can use the graphical interface. So for MATLAB, let me go to the MATLAB example. And here I also provided you with some exercises that you can follow. The first one, and the one that I will try, is the serial case, right? And there are 3 files here. One is the submit file.m, and this is used on the MATLAB GUI, right? With this script, you can submit the job through the to the queue using the MATLAB GUI directly. And this file here does the same, but it uses the sbatch command, the one that we have been using up to now. So these are 2 ways of running MATLAB. So I will try this one. And first of all, we need to load the MATLAB module. It's recommended always to purge in case you don't remember what modules you have loaded already. Then I will search for MATLAB and see what versions are installed. Once I have the versions, I will explore the modules or the dependencies that I need to load. So it seems that here it says the module can be loaded directly. So I will load the module. I use this command, the shortcut ML, which stands for module load, and then the module of MATLAB, right? And I start MATLAB with this flag here that is mentioned in the exercises, and it's the single com thread. So in general, MATLAB and other software like R can start several threads, right? Simultaneously. So it makes a problem because if you're using several threads on a single on the login node, then you will occupy a lot of resources, and the jobs of the other people that are logged into this node will be experiencing some delay. So it's better to use just a single thread when you are working with MATLAB. So let me see if it opens. Yes, it works, I hope. My MATLAB, let me see what it is. It's here. Yes, you see. I'm in Windows, but I'm displaying the MATLAB that it's on Kebnekaise. Now I will open my files, submit, and the real file that does the computations with this funct.m. So basically it does a Fourier transform operation on some matrix, and then at the end it writes some output, some log file. Right? This is just the way to launch the script, yes, using the MATLAB GUI. Yes, something that is mentioned in the exercise and the README file is that the first time that you use MATLAB, you need to run the command config cluster, yes, and then follow the instructions there. So I will do it, and it asks you for two options, Abisko and Kebnekaise. Abisko is retired, so I will press Kebnekaise. So then it shows you some options here, and it tells you you must set some variables, which I will copy and paste. The first one is the park cluster name, which is Kebnekaise, and you should leave this name as it is. The next thing is the account name, and for the account name is a project that you have been granted. In particular, this is SNIC 2021, 22, 514, right? So I will put also some additional flag for the default time, and in particular 10 minutes should be okay. So in addition to this, you need to add extra flags if you want to use the GPUs. So this is mentioned here in the README file of the MATLAB directory. So click on this link in the README file, and this will get you to the MATLAB configuration file. If you notice, for the GPUs, you need to add 2 extra lines, which I will do right now. And they are the type of GPUs that you want. In this case, K80. And the next one is the number of GPUs per node, in this case, 2. Finally, I can save the profile as suggested by this line here, save profile. Now you're done. So the cluster should work. So what can you do now? Just take this case here, the submit.mm file, and then press run, right? So I will do that. I press run, and when I do that, and I move to the Kebnekaise node, and I search for the jobs that are being submitted. I see that the MATLAB job, it's running, right? So it's doing something, and at the end, I should see the results. And they are here. It's written in the log file, and that's it. So try to do the exercises that are provided by in the folder, and if you have any question, just let me know. So now I will close my MATLAB. Okay. So there are several exercises that you can try with MATLAB. There is a example for parallel simulations using part 4. Another way to do parallelization is by using SPMD, and a GPU case, which is very interesting, and it solves a Mandelbrot problem. Okay, MPI-CUDA is an example that was requested by a user some courses back. And essentially here, I'm showing you the way to do a programming where several MPIs or more than one MPI can use a different number of GPUs. So it's a multiple GPU program. And this is some guideline to do the programming. The program is very simple. And essentially, it's calling just MPI and then printing out the ranks on the CPU. Although it's quite simple, it's very instructive if you already have your application that runs on GPUs, but you want to parallelize that even further with with MPI-CUDA. Okay, let me go now to the next software, and this is NAMD. Here I also give you some exercises in the Markdown document, and there are some ways to run NAMD, and in particular, I provide you with the two cases. MPI is one of them, and the other one is by using GPUs. So try to follow also the exercises and let me know if there is some issue or if there is something that you want to discuss. Pytorch is an example that I showed you previously. Some person asked about that. So if you have your Python code, in this case is this a script, Pytorch gpu.py, then you need to load the modules. For Python, in this case, it uses Pytorch, and also the MATLAB, the libraries that you need, the modules, the matplotlib, and first of all, the tool chain, yes, the compilers that are needed for Pytorch. And the way to submit it is by using the srun command, Python, and the name of your script. So if I'm going very fast, just let me know, and I can go slower. So here is the example for R, and also there are several exercises that I wrote for you. So these are some scripts that can run in parallel using the do parallel and some machine learning scripts. So try to follow these examples. As in the case of MATLAB, you need to do some additional configuration the first time that you run the scripts, and the instructions are given here in our website. Yeah. So try to follow the exercises and let me know if there is some issue. In the case of TensorFlow, there are 3 examples. One is a simple hello world, and also the computation of loss for one simple model, and the MNIS example, which is also very simple but very instructive. And in the script job tensorflow.sh, you can find a way to submit it. Yes. So I see that there are some questions on the chat. I will address them. And you may try all these examples or the ones you're interested in, and let me know if there is some issue, or maybe you want to run also your application. You have compiled that and you want to run it today, so we can try that.